Hello everyone, welcome to my channel. This video is about guided module tutorial chapter 11, amine. So let's check for the question number 1. Okay, so first of all, the question asks, draw the general structure formula for primary, secondary, and tertiary amine. Actually, this is like 1 mark question. It's quite simple. So you just need to show, okay, primary amine, right, it will attach with one alkyl group. So you have to always remember, right, okay, nitrogen, the bonding maximum is 3. There are 3 bonding for nitrogen atom. So this is ammonia. So primary amine, right, will attach with R group. Secondary amine, right, will attach with 2 alkyl group. Okay, alkyl or aryl group. Tertiary amine attach with 3 alkyl group. So these are the general formula for primary, secondary, and tertiary amine. Okay, next is about naming. Okay, as I explained just now, right? Okay, you have to check the amine whether it's primary or secondary or tertiary, because different class of amine, right, the way to name is different. Okay, so for example, I classified them first. So this nitrogen with 2 hydrogen, I know is primary. With 1 hydrogen is secondary. So 2 hydrogen primary. Okay, actually for me, right, much more easier to identify the hydrogen. Actually, it have to base on alkyl group. Okay, so okay, there is one alkyl group for here. So this one there are 2 alkyl group. That's why it's secondary. Okay, and then for this one, okay, attached with the whole a big alkyl group. So for this one, attached with a big alkyl group. But I also can identify based on the number of hydrogen atom. So because one as I say just now, right, nitrogen with 3 bonding. Since it's attached with one alkyl group and then there are another 2 hydrogen, meaning that this is primary amine. Okay, for this one, right, there is no hydrogen, so this is tertiary amine. So for the secondary amine, right, it will end something. So for tertiary, right, end something. Okay, end something. So primary is much more easier. So for check, right, this is 1 carbon, 2 carbon, 3 carbon, right? So straight away, propane amine. Okay, don't forget you have to put the position, because the amine group, right, I can put as C2 as well. So that's why we must put the 1, position 1 for the amine group. So this is 1 propane amine, primary amine. Okay, for this one, right, okay, here with one alkyl group, here with another alkyl group, you have to check for the name for this alkyl group. 3 carbon, right, is propane. Here also 3, is it 3? Yeah, 3 carbon as well, propane. So N isopropyl, 2 propane amine. So one side, right, you have to according to the IUPAC name, because here, okay, this one C1, C2, C3. So 2 propane amine. Actually, this one also the same. Actually, this one also the same. Here also isopropyl, here also isopropyl. But another one, right, we will have to make it become the parent change. So this is the parent change. And then this one like something like substituent, isopropyl. Okay, so we have to put the N for the secondary one. Okay, for B3, right? Okay, I try to expand it. Okay, so C, okay, H2, and then here N, H2, and then there's a C with a hydrogen, and then here CH3, and then phenyl. Okay, that means there is a benzene ring. So we try to assign the position. So this one is C1, C2, C3. So at the position 1, right, so this is 1 propane amine. 1 propane amine, and then at the position number 2, there is a phenyl group. Okay, benzene ring as a substituent. So the name for this compound, right, is 1 propane amine and then 2 phenyl. So 2 phenyl, 1 propane amine. Yeah, 2 phenyl, 1 propane amine, which is a primary alcohol. Primary amine. So notice, right, if secondary, it will start with N. Okay, if primary, straight away the name. Okay, and the substituent and the parent change. Okay, next. Okay, this one is benzene ring. Okay, benzene ring with NH2. So we will call it this one as aniline. This one as aniline. So position 1, position 2. So 2 chloroaniline or 1, 2 is O chloroaniline. So 2 chloroaniline or O chloroaniline. Okay, third one, yeah, this one is quite interesting because this one is tertiary amine, right? How to name it? Okay, you have to identify which one is the parent chain. Okay, this one has more carbon, so this is aniline. So this one is aniline. Okay, aniline, okay, because there are 6 carbon, I will put this one as the parent chain, aniline. And then this one is ethyl, and then another one is propyl. So N-ethyl and propyl aniline. N-ethyl and propyl aniline. Okay, for this case, right, okay, you have to be careful, because this is N, even though N is alphabetical, but this N have to write in capital letter, and then with the substituent, okay, have to be dash. So you just assume that the N actually like number N dash ethyl dash N dash propyl aniline. Okay, now we proceed with drawing. Draw, okay, the structural formula, okay, for the following compound. So propane amine. So have to draw 3 carbon and then the NH2 right at the position number 2. Okay, quite simple. So position number 2, propane amine. Okay, next, 3-amino benzoic acid. So benzoic acid, still remember what is benzoic acid? It's a benzene ring with COH, and then 3-amino, right, means the NH2 group right at the position number 3. So this one is benzoic acid. So this one is the benzoic acid. So this is position 1, position 2, position 3. So now you know, right, when amine group become substituent, we name it as amino. When amine group become as substituent, we call it as amino. Okay, so 3-amino benzoic acid, because carboxylic acid have to give the priority. Okay, next, N-butyl N-ethyl aniline. This is tertiary. Based on the name, I know already. This is tertiary amine. This one is tertiary amine. Okay, this one tertiary amine as well. Okay, so let's check. N-butyl N-ethyl aniline, meaning that you have to put an aniline. Okay, so this is aniline. So for the aniline, right? Okay, N-ethyl. So this is N-ethyl with 2 carbon. N-butyl, there are 4 carbon. Okay, D, N-dimethyl, 1 butane amine. Butane amine, so you have to draw like this. 1, 2, 3, 4. Butane amine here, right? N. Okay, and then there are 2 methyl groups. So here C, C. Is it the same? Okay, and yeah, N with 4 carbon, and then CH3, CH3. Okay, this one is the proper condensed structure. Okay, if you cannot see, right, you can explain like this. Okay, so here this is CH3, CH3. This is why the answer given, right, CH3 bracket 2 lah. Here, okay, please do remember you have to complete the carbon. So this carbon with 2 hydrogen group. Okay, CH2, this carbon CH2, this carbon CH2, and then this carbon CH3. Okay, now try methylamine. Actually, this one also tertiary. This one also tertiary amine. In this case, this one also tertiary amine. So like this. Okay, trimethyl. Straight away trimethyl amine. Okay. Now we proceed with question 3. Ask about physical properties. Okay, the first one is about boiling point. The second one is about solubility. Okay, so the question requires, right, explain why boiling point of N-dimethyl methylamine is 4 degrees Celsius. So this one is tertiary amine. Okay, and then while 1 propane amine is primary amine. Okay, it's primary amine is 49 degrees Celsius. Okay, actually, right, we have to know, right, primary amine can form more, has hydrogen bonding, while tertiary amine just weak, when can form weak van der Waals forces. Okay, compare in terms of this, right, we know hydrogen bonding is stronger than van der Waals forces. So meaning that primary amine, right, okay, if you want to break the bond, okay, the hydrogen bond for the primary amine, right, you need more energy. That's why the boiling point for 1 propane amine is higher. Always remember, okay, even though tertiary amine, okay, seems like, okay, there is a nitrogen can form hydrogen bond. Actually, no. If you draw the structure, right, for this one, methane amine. So methane amine, right, attached with N. So methane, okay, and then N-dimethyl. So actually, it's like this. N-dimethyl methane amine, right, actually same as this name. This one, trimethylamine is the same. Trimethylamine and N-dimethyl methylamine is the same compound. Okay, impossible for this nitrogen bond to form hydrogen bond with form hydrogen bond with another hydrogen. That means it can impossible to attach with hydrogen to form bonding because it already at maximum bond for nitrogen is 3, already attached with carbon. So impossible for tertiary amine form hydrogen bond. It only can form weak van der Waals forces, which is weaker compared to hydrogen bond. Okay, and then compare the solubility. Trimethylamine actually is the same as an dimethylamine and methylamine. Okay, this one with 3 alkyl group. This one only with, okay, like this, CH3, okay, and H2. Okay, like this. For sure, right, this one higher. Okay, methylamine is primary amine. Okay, yeah, this is primary amine. Okay, and then this one is tertiary amine. So primary amine, right, more soluble in water. Why? Because it can form more hydrogen bond with water compared to trimethylamine. Okay, trimethylamine actually, right, it didn't form, only form the hydrogen bond with the nitrogen here. Okay, yeah? And then for this one, right, it can form hydrogen bond like this, hydrogen bond like this. It can form hydrogen bond like this. Okay, so primary amine can form more hydrogen bond. Okay, you have to be careful. A is asked about boiling point. B is asked about solubility. If solubility, right, the nitrogen can form hydrogen bond with by using the nitrogen atom. Okay, form hydrogen bond with the water, the H atom over here. Okay, now we proceed with question 4. Question 4 also is boiling point question. Okay, if here, right, you have to be careful because now we have to compare with different group of compound, means different functional group. This one alcohol, this one just alkene, this one amine, this one amine. Okay, and then you have to know, right, this is primary amine, and then this one also primary amine, but this one got branch, so branching. Okay, branch. This one linear, straight change, linear or straight change. This one just alkene. Okay, like alkene. Okay, so for this one, definitely butano higher. Okay, check Okay, ascending order. Ascending order. Do you understand what is ascending order? 1, 2, 3. From lower to higher. So the lower one is this one. Okay, and then between these two, right, linear higher. Okay, you check 1 carbon, 2 carbon, 3 carbon. So this one 3 carbon. 1 carbon, 2 carbon, 3 carbon, 3 carbon. So consider as isomeric amine. Isomeric amine. One is propene amine. Another one is, okay, 1, 2. Okay, 1, 2. Okay, 1, 2. Also, okay, how to name this compound? Okay, like this one, C, and then the branch is here, like this, and then here is N, H2. So this is 1, 2, 3, 2. Okay, this one is 2 propane amine, 2 propane amine. This is 1 propane amine. Okay, so this is secondary. No, still primary because one alkyl group, but this is 2 propane amine. 2 propane amine. This is 1 propane amine. Branch I consider as branch, so this one is second, this one is third. Okay. So and then the highest one is sure alcohol lah. Alcohol. So now how are you going to explain? Check one by one. Alkene cannot form intermolecular hydrogen bond. Cannot form intermolecular hydrogen bonding. Only has weak van der Waals forces. Okay, you have to remember, alkene cannot form intermolecular hydrogen bond. It only can form it only has weak van der Waals forces. That's why it has the lowest. So lowest among. So alkene has the lowest boiling point among all. Okay, next. As I explained just now, right, amine and alcohol, right, okay, there are 2 amine, all can form intermolecular hydrogen bond. So this is the similarity, okay, for these 3 compounds. But why oxygen, okay, sorry, why alcohol is highest? Is the highest because it's due to oxygen is more electronegative than nitrogen atom. So will make the hydrogen bond in alcohol stronger than amine. Therefore, okay, compound 4 means alcohol, right? Propanol has the highest boiling point. While for primary amine, right, okay, one is two propionamine, another one is one propionamine, right? Okay. Okay, again and again, similarity. Okay, this is the similarity between the two amine. Both are primary amine. But, okay. What is the similarity? Form the same number of hydrogen bond. However, linear molecule, okay, is higher boiling point compared to branches molecule. Okay, so you have to explain. Okay, the three, this is linear, and then this one is branches. This one is linear or straight change compound, and then this one is the branch amine. Okay, so the surface area of contact for two, okay, the linear one, the straight change amine, right, the one propionamine, right, is larger, so it has stronger van der Waals forces compared to the branches amine. Okay, this concept exactly same as what you have learned in alkane, the isomeric alkene. Okay, the straight change hydrocarbon, okay, has higher boiling point. Why? Have always remember, must explain due to the larger surface area of contact, stronger van der Waals forces. Okay, B, chloroethane. Okay, this is haloalkane. Okay, this one is amine, this one is alcohol, this one is butanoic acid. So it's very obvious because four of the compound, right, is different compound, different functional group. So automatically, right, we know chloroethane cannot form intermolecular hydrogen bond, meaning that it only has weak van der Waals forces. That's why it has the lowest boiling point amount or for chloroethane. Next is okay, again and again and again, you must explain the similarity. So not both, three of the compound, amine, alcohol, and ethanoic acid, all can form intermolecular hydrogen bond. Okay, alcohol, right, is higher than the amine because oxygen atom is more electronegative than the nitrogen atom. So it can form a stronger intermolecular hydrogen bond. Okay, if compared between one propionamine and one propanol. So one propanol has higher boiling point than one propionamine. Next is for ethanoic acid. As we know, ethanoic acid has the highest boiling point. Why? Because it can form more intermolecular hydrogen bonding and exist in the form of stable dimer. Okay, must mention it can exist in the form of stable dimer. Okay, which you have learned in previous chapter. Okay, now question 5 is the question 5 is the type of question I like the most. Okay, I always say this one is question ha ha ha. When you see this kind of question, you have to laugh. Not only smile, you have to laugh because straightforward, you know what is the compound form. Okay, so this is haloalkene. Okay, for haloalkene, right, we learned this before. How to form amine. Okay, undergo nucleophilic substitution. If you forget already, never mind. We just have a quick review. Okay, still remember this one? Okay, under chemical reaction of haloalkene, nucleophilic substitution. So the haloalkene react with amine. So it will replace, okay, means substitute the haloalkene, the halogen atom, okay, and then substitute NH2. I always say, right, okay, you have to alert that the N is attached to the C. And then this, because this is amine, is much more easier. If it change to ethyl amine, primary, secondary amine or tertiary amine, right, you have to check for the bonding. Okay. So now let's check what is the compound A. So compound A is a reagent. As we know, right, this is must come from amine compound. And then initially, right, only one ethyl group. Okay, and then now you check for the product, there are two ethyl group, meaning that compound A is an amine compound with two methyl group. So I can deduce, right, the structure should be like this: CH3, CH2, and then NH2. Okay, react with the CH3, CH2, Cl. It will eliminate the H, one of the hydrogen from the amine and one of the hydrogen and Cl, it forms HCl. So now, okay, it can join. Okay, so CH3, CH2, and then attach to this carbon. So CH2, CH3. Okay, since this ethyl, right, I can bracket it as CH3, CH2, there are two ethyl groups. So the answer for compound A is this one. So this is the answer for compound A. Yeah. Okay. Ethane amine. Okay. Now let's look at question B. B, okay, so this one is nitrile compound and then undergo reduction. So nitrile compound undergo reduction, right, as we know, it will form CH2Cl. So if you forgot already, right, never mind, let's check it together. So you go for, okay, the reduction of nitrile compound. Here, yeah, this is the reduction of nitrile compound, okay. You can use, okay, lithium aluminium hydride, sodium boron hydride in methanol, okay. This is the C triple bond N, and then reduce becomes CH2 and H2. Okay. So you just copy and paste for this part, okay, and then this nitrile compound will become CH2 and H2. Yeah. Okay, for C, right, okay, we notice, right, okay, the C double bond O becomes CH2. The C double bond O, the carboxyl amide, right, okay, becomes CH2. So sure will undergo reduction. Okay, you have to double check the rest, is it the same? Yeah, CH3, CH3, here CH3, CH3, and then CH, CH. Okay, the number of carbons still the same, huh? The number of carbons still the same. So if you check from here, right, this one, okay, the number of carbons still the same, and then it will reduce from the primary amide become primary amine. So using the reducing agent. Okay, please remember for this case, right, 1 Roman lithium aluminium hydride, 2 Roman H2O, H2O, not H3O plus. For this case, the reduction of amide, right, the reducing agent is 1 Roman lithium aluminium hydride, 2 Roman H2O. This one really insists H2O. Please remember about it. Okay, so the reagent for compound C, right, is 1 Roman aluminium hydride, 2 Roman H2O. Okay, D. D is using SnHCl. So this is the reducing agent for nitro compound. Okay, nitro compound, right, it might be 2 nitro compound or 1 nitro compound. Okay, we check from here, nitro compound. Yeah, this one is nitro compound. So by using this iron acidify or zinc acidify or SnCl2, stannum chloride acidify. Okay, so NO2 will reduce become amine. So there are two possibilities for this answer, whether it's two nitro group or one nitro group. Okay, the last one, compound E, right? Okay, if we check, right, initially there are 3 carbon and then now become 2 carbon, meaning that, okay, the C double bond O totally, okay, cancel off, okay, totally disappear. So in this case, right, we have to use a special reagent for this case. Okay, the reagent that we should use is, suppose is bromine, base, sodium hydroxide, and then water. Okay, this one you can check for the lecture notes. Also, you give the same thing. Okay, you can check for your lecture notes, right? Okay, this one is this one, Hoffman degradation of primary amide. So the primary aryl or alkyl group, right? Okay, it will eliminate. Okay, the elimination of carbonyl group is shortening the length of carbon change by 1 carbon atom. So the way to write down the reagent should be bromine plus sodium hydroxide water, or like this, bromine, sodium hydroxide water. So for me I prefer this one. Okay, so it's up to you. You can follow, because just follow lecture notes. Okay, so both methods acceptable. So the answer for the reagent A is, okay, bromine, and then OH, and then aqueous. Make sure aqueous insists, and then H2O. Okay, now we proceed with question number 6. This is synthesis. Okay, synthesis. Show how 2-methyl-1-propene amine can be synthesized from 2-propanol, meaning that this is the reactant. This one is the reactant, and then this one is the product. Okay. Okay, you try to draw propanol. Okay, you try to draw 2-methyl-propene first. Okay, 2-methyl-propene. Okay, 1, 2, 3, and then the amine at the position 1 and H2. Okay, 1, 2, there is a methyl group. So for this case, right, okay, this is the product. Okay, you try to, this is the simple version first. Later we have to complete the hydrogen atom. Okay, this one is the product. And then from 2-propanol, 1, 2, 3, and then there's alcohol at the secondary carbon. Okay, this is a secondary hydrogen, secondary alcohol. Okay, if you notice right here, 3 carbon compound, and then here 4 carbon compound. So first of all, right, we will think about nitrile compound. Okay, CN. I will think about CN. Okay, CN negative. So I will think about the KCN. Alcohol, I will use the ethanol, must be specific, and then reflux. So for this case, right, normally, okay, if you want to form the nitrile compound, right, okay, we have to start from haloalkene. We have to start for haloalkene. Means something, okay, for example, CCCl, right, haloalkene undergo nucleophilic substitution, okay, when react with KCN, and then it will form CCCN, some sort like this. So now in this case, okay, so this is the 2-propanol, right? So I will try to think about, I need to form haloalkene. So I can use SOCl2, PCl3, PCl5, or HCl, and then form haloalkene. Okay, from haloalkene to haloalkene, secondary haloalkene, sorry, okay, to chloropropane. Okay, now it undergo nucleophilic substitution. This one is nucleophilic substitution, as I said just now. Okay, NaCN, right? Okay, okay. I will insist on this one because it's according to a lecture note, right? Is KCN in ethanol and then reflux or heat. So CN is replaced. Okay, when CN is replaced, is substituted, right? When CN is substituted, now yeah, check yes. Okay, it can form amine already. If you form amine means you need to reduce the nitrile compound. So by using lithium aluminium hydride 1 Roman, 2 Roman H3O+, so it becomes CH2 NH2. Okay, now you check. Okay, this is 1, 2, 3. So 1 propene amine. This one 2 methyl. Yeah, this is how the 2 methyl 1 propene amine can be synthesized from 2 butanol. Okay, yeah. So all of this, right, you have learned before. You have learned before. So this is substitution. Alcohol substituted. Okay, substitution. And then for haloalkene undergo nucleophilic substitution. And then after nucleophilic substitution, from nitrile compound reduced become, okay, amine. So I always keep on remind you, all right, you have to do something you have learned. Okay, for organic chemistry, you must show something that you have learned. Don't create by yourself. Okay. Organik kimia memang kena buat sesuatu yang anda pernah belajar. Okay, tak boleh reka sendiri. Reka sendiri tu biasanya akan salah. Okay. So now kita sambung soalan 7. We continue question 7 again synthesis. Show the two-step reaction. Okay, the question emphasizes on two-step. Okay, if the question didn't mention about two-step, right, you can do for 3-step, 4-step, no problem. So for example, like this case, 1 step, 2 step, 3 step. But this case, right, only 2 step. For the conversion of 1 methyl cyclohexane, okay, 1 methyl cyclohexane, okay, no, okay, 1 methyl cyclohexane is what? 1 methyl cyclohexane, okay, 1 methyl cyclohexane to 2 methyl cyclohexane amine, become 2 methyl cyclohexane amine. So meaning that from double bond becomes single bond, okay, from double bond becomes single bond. So I will think about electrophilic addition. I will think about electrophilic addition. Why? Because involve carbon-carbon double bond. So the product form, right, is 2 methyl cyclohexane. This one become, okay, this is position 1 and this one is position 2. So I know, right, I can substitute NH over here. So if I substitute NH, right, I will have to make sure that this one is haloalkene. Haloalkene is very useful. Okay, but I have to ensure that this haloalkene, right, this bromine or chlorine atom, right, okay, normally we use bromine, must add position at this position. Okay, if adding HBr, right, according to Markovnikov rule, okay, if you check out 1 bonding, 2 bonding, 3 bonding, 4 bonding, 1 bonding, 2 bonding, 3 bonding, meaning that here there is a hydrogen. So when H and Br is added to this carbon-carbon double bond, right, by right H, this electrophile have to add it to the side with greater number of hydrogen, and then Br have to add it over here, and then become single bond, if according to Markovnikov rule. If the bromine is over here, when it react with NH3, right, so suppose, right, if you react, it will substitute over here, NH2. But the problem, right, I want to add it to another carbon. Okay, not the same carbon. If not the same carbon, so we have to think something. So now, if you still remember, we learned about Markovnikov rules. We learned about Markovnikov rules. We also learned about anti-Markovnikov rules. So meaning that I want the bromine added to here, and then the hydrogen added to here. Not follow the Markovnikov rules. So in this case, I can add peroxide. Okay, ROOR. So the example, right, H2O2. Okay, over here. So that the bromine will add it to the side with grade. Okay, the bromine means, okay, not the electrophile. The electrophile is hydrogen. Now the hydrogen added to the side with less number of hydrogen. Automatically bromine atom is added to this side. Here. So and then undergo substitution, nucleophilic substitution, and then the ammonia is added to here. Okay, hope you all can understand. Okay, what is the product form when one methyl cyclohexene is treated with hot acidified solution? Okay, this is the oxidative cleavage. Okay, oxidative cleavage. Oxidative cleavage, okay, I erase everything. Let's check together. So it will break the bond. Okay, due to this one is cyclic compound, this is cyclic cycloalkene, cyclohexene. So meaning that it only form one product. So you break the bond, double bond O, if you form double bond O over here, double bond O over here. And then there is one hydrogen over here, it will continue hydrolyze, become OH. So that's why here forms COOH. So this one is the C1. Okay, and then C2, 3, 4, 5. C2, C3, C4, C5. And then C double bond O from this side, and then there is a methyl group. So this is the answer. Okay, because for this carbon, right, there is no hydrogen. That's why it's just form double bond O, which is ketone. Okay, so for the oxidative cleavage, when using KMNO4, right, okay, we have to check, is there any hydrogen? After form the C double bond O, is there any hydrogen attached to that carbon? If yes, it will continue oxidize, become carboxylic acid. If no, it will remain as ketone. Okay, yeah. If after cleavage, right, it remains CH2, it will form CO2 plus H2O. If you forgot already, right, you can check, okay, by IG or Facebook. Okay, you look at the slide here. Yeah, this one. Oxidative cleavage of alkene, hot acidified water. This is what I mentioned. If remains CH2, it will form CO2, H2O. Okay, after cleavage from double bond O, if there is a hydrogen, it will form carboxylic acid. If after cleavage there is no hydrogen, it's just copy and paste from ketone. Okay, but for oxidative cleavage for ozonolysis, right, it's much more easier. You just break the bond, double bond O, double bond O. Others just copy and paste. Okay, now we move on to question number 8 is about basicity. Ascending order means from the less basic, okay, and then increase basicity. So for less basic one, right, suppose got phenol. Okay, phenyl group, because phenyl will decrease acidity. Okay, for increased acidity, right, make sure there is EDG. EDG normally is referred to the R group. So for here, right, this one is the R group. This one without R group, so this is the reference at the set at the middle. Okay, and then NO. Okay, so I try to arrange first. This one sure is the highest one. 4 is the highest. And then this one should at the middle. Okay, third one. Okay, because here there is a benzene ring, this is a benzene ring. Okay, now we have to check for the nitro group. What is the function of nitro? Nitro is electron withdrawing group. If electron withdrawing group, right, meaning that, okay, withdrawing group, okay, which will withdraw the lone pair of the nitrogen. When it withdraw the lone pair electron from the nitrogen, right, it will make it become less basic because it's tend to release the hydrogen. It will tend to release the hydrogen. Okay, so making the basicity for this nitroaniline, right, is less basic. So if less basic, right, meaning that this is number 2 and then aniline is number 1. Okay, so or less basic. Less basic. Okay, sorry, wait, ascending order of basicity. Okay, yeah, sometimes we will get confused. That's why you have to double and triple read the question. Ascending order of basicity. So the most basic one is methanamine, followed by ammonia, and then it's between aniline and p-nitroaniline. Less basic is this one. This one is less basic. So this one is number less basic. Okay, less basic means this one. This one is 2. This one is more basic. Okay. So now the sequence is, okay, p-nitroaniline is the least basic one, followed by aniline, then ammonia as a reference because there's no electron withdrawing group or phenyl group or electron donating group. And then next is methanamine because it's got EDG. EDG will increase the basicity. So now we check the explanation. Methanamine, okay, slightly stronger base than ammonia. Why? Presence of alkyl group. So you have to always remember the alkyl group, right, is an electron donating group. Make the methane amine more basic. Okay, make the methane amine more basic. Next is about aniline. Okay, next is about aniline. Aniline is weaker base. Why? Than ammonia. Okay, because the lone pair of the electron, right, on the nitrogen of aniline delocalized into pi electron system of the aromatic ring. So as I explained just now, right, this one aniline, right, the nitrogen the nitrogen atom over here, right, will delocalize over the benzene ring. Okay, make it less stable, less stable. Okay, so easier to remove the hydrogen atom. Well, easier to remove the hydrogen atom, right, meaning that it will decrease the basicity. Okay. 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 Decrease the basicity. It means weaker base. If p nitro, okay, p nitro is electron withdrawing group. So if it automatic, since EDG increase the basicity, EWG should decrease the basicity. So we draw the lone pair of electron from nitrogen aniline more strongly, and this make the basicity of p nitro aniline lower than aniline. Okay, this is the explanation. But no worry, okay, normally, right, based on previous experience and then past year question, right, the question seldom ask about basicity. So you just focus on acidity. Okay, but you have to know the basic concept as well. Okay, at least you know, okay, okay, the difference between EDG, right, which will increase basicity but decrease acidity. If EWG increase acidity but decrease basicity. Okay, phenyl group, right, phenyl compound, right, can the resonance structure can increase acidity, but it will for the amine one, it will decrease the basicity. For acidity, yes, it will increase. Okay, it will increase the acidity, but for aniline, decrease basicity. The phenyl compound decrease the basicity. Okay, now question number 9 is about okay, nitrous acid. Nitrous acid is a chemical test to differentiate the primary, secondary, and tertiary aliphatic amine and primary, secondary, and tertiary aromatic amine. So you must be very clear the compound. Okay, you have to make very clear the class of the compound. So 18 amine. If you're not sure, you just draw out 1, 2 amine. Okay, so like this. So this one is primary. Okay, next, N-methyl methylamine. Okay, N-methyl methylamine, right? Okay, for this one, okay, based on the name, right, I can deduce the class of amine already. For B is primary, and then for C is tertiary, because NN. Okay, so if you're not sure, right, you can draw it. Okay, methane amine, right? So methane amine, and then there is a methyl group. Okay, so N-methyl methane amine. So this one is hydrogen. So this one is secondary amine. So this one is primary amine. Okay, and then this one NN dimethyl. So here nitrogen. So dimethyl CH3. Okay, and then CH3. And then the parent change is 18. So CH2, CH3. So there are three alkyl groups. So this is tertiary. Aniline is like this. NH2. So this one is primary aromatic amine. This is primary aromatic amine. For A, B, C, all is aliphatic amine. All are aliphatic amines. Okay, so when it react with, okay, the primary amine, 18 amine, react with nitrous acid test, make sure that you write the reagent correctly, and then the condition must be 0 to 5 degrees Celsius. It will form 4 compounds. Okay, since there are 2 carbon, right, so here will form ethane, ethanol, and chloroethane, and nitrogen gas as well. So this is the product form when the primary aliphatic amine react with nitrous acid. Okay, for secondary amine, right, it will form a yellow oil compound. So this one, for A, right, it will form, the observation is bubble gas form. Bubble gas form. Okay, this is the observation for the primary aliphatic amine. For secondary aliphatic amine, right, okay, it will form yellow oil. So NO. Okay, the H replaced by NO. Okay, next for tertiary amine, what happened? For tertiary amine, right, it will form salt. Okay, it will form salt. Okay, you just copy and paste everything. This one, just copy everything. Okay, and then form Cl negative. Okay, another one also the same. Just copy and paste everything, and then the N, right? Okay, N will form NOCl2. NOCl2. Wait, suppose it's like this. Okay, so should be like this. Okay, you just notice right here, you just copy and paste everything. Okay, you just copy and paste everything, and then this part is HCl negative, and then N positive. Another part, right, is N positive, and then NOCl negative. Okay, so if you're not sure, right, you look at the tertiary. Okay, we look at summary notes for. Okay, this is the nitric acid test. Okay, here, right, you check. Okay, you just copy everything, and then the H over here. Okay, and then becomes Cl negative, and then NO over here becomes Cl negative. Okay, Cl negative put outside. It's up to you. Actually, all acceptable. If you check for lecture notes, how the lecture notes writing for the nitrous acid compound. Okay, the nitrous acid product. Sorry, the nitrous acid product. Let's check. Okay, every time, right, if you feel confused, right, you can refer back to lecture notes or any reference book. But since since we are using we follow CAMPK, right? So we check for the CAMPK lecture notes. Okay, for the nitrous acid, okay, always remember. Okay, nitrous acid, right, is HNO2 is a weak and unstable acid. So it is always prepared in situ by treating with cold sodium nitrate and NO2 with aqueous solution of a cold dilute hydrochloric acid, which is HCl at 0 to 5 degrees Celsius. So nitric acid react with all classes of amine. Okay, primary aliphatic aromatic, okay, secondary and tertiary aliphatic aromatic. Oh, okay. This one, okay, it can use to identify, differentiate primary aliphatic and primary aromatic. Why? Because, right, for primary aliphatic, okay, it will form nitrogen gas, so formation of gas bubble. But for primary aromatic, just form a clear solution, which is a benzene diazonium salt. Okay, there is no gas bubble form. Okay, and then you have to be careful if the temperature, right, above 10 degrees Celsius or the solution is heated, right, it will form nitrogen gas as well. So if you want to differentiate between primary aliphatic and primary aromatic amine, make sure that the temperature is at 0 to 5 degrees Celsius. Okay, and then it also can use to differentiate, okay, the primary, secondary, and tertiary aliphatic and aromatic amine. Okay, so I need to look at the tertiary, okay, the tertiary aliphatic, you see? This is the product. So you just copy and paste all the alkyl group and then put a H over here for compound A and then with Cl. Okay, for compound B, you just copy everything, all the alkyl group and then form N double bond O Cl negative. So please do remember the N must with positive charge. The N must with positive charge. And then, okay, just now I bracket wrongly. Suppose here. Okay, it's bracket here. Okay, this one NOCl negative. So always remember Cl negative at the outside, and then must remember the N must with positive charge. N positive, and then attach with NO, then bracket Cl negative. N positive, okay, attach with hydrogen, and then bracket Cl. Okay, for D is, okay, D is, what is D? D is, aniline. Aniline react with nitrous acid, right? Okay, it will form, okay, salt. Okay, benzene diazonium salt. Okay, benzene diazonium salt. Okay, now we look at question number 10. Okay, just a quick review lah. For this one, benzene diazonium salt, right, it can react with phenol as well, if you check from here, right? Okay. This one is the primary aromatic amine, react with the nitrous acid, okay, it will form benzene diazonium salt, okay, only stable below 5 degrees Celsius. This benzene diazonium salt, right, okay, yeah, it can react with phenol, form an orange dye, okay, and then also can react with NN dimethylaniline, okay, form a yellow dye, form a yellow dye. So how this compound is formed actually is quite simple. Just, okay, you just remember, eliminate HCl as well. Eliminate the H. Okay, this one you just copy. Okay, you just copy everything. Not eliminate. Sorry, not eliminate HCl. The hydrogen over here, right? Okay, yeah, it's eliminate HCl. Yeah, correct, correct. Eliminate HCl. Okay, eliminate HCl and then join over here. Okay, here also the same. The hydrogen over here, right? Eliminate the HCl and then join over here. So add the phenyl, okay, and diazonium, right? Okay, and triple bond N. Okay, we'll straight away attach. Okay, straight away attach. Okay, with this reagent. Here also the same. Straight away attach with phenol. Okay, with phenol orange dye with NN dimethane. Okay, sorry, NN dimethyl aniline. It will form yellow dye. Here. Okay, now we look at question number 10. Show how the following compound can be synthesized from benzene ring, meaning that the starting point is benzene ring. Okay, from benzene ring, okay, need to form carboxylamide. So meaning that in this case, right, benzene ring, it will form ammonia compound, right? The first thought I would think about nitration. Yeah, nitration. So only benzene ring, benzene ring can react with the concentrated sulfuric acid and concentrated nitric acid at 50 to 55 degrees Celsius. This one only happen on benzene ring and then form nitro compound. Okay, and then nitro compound, right, reduce. Okay, by using this reducing agent, right, it form amine. And then amine, right, can react with the acyl chloride. Okay, acyl chloride. Okay, so it will eliminate the H and then Cl and then the N will be attached to here. So when the N, okay, attached, right, it forms carboxylamide. So this one is the compound. So involve 1 step, 2 step, 3 step. Okay. Second, okay, the second question. The second question is about C double bond O and H, okay, carboxylamide as well. But this time the position is different with A. This time the position is different. This one is C double bond O, the benzene ring is here. And then it's C double bond O. And then here nitrogen, okay, with a methyl group. Okay, like this. So, and then there's a one hydrogen. So you have to think about it. Okay, C double bond O. I think it involves Fieldcraft oscillation. Am I right? Oh, alkylation, not oscillation. If you look up oscillation, acyl. Okay, oscillation means, okay, the alkyl group is substituted and then undergo oxidation, it will form carboxylic acid. So this one is benzoic acid. Now, benzoic acid, right, okay, react with, okay, methylamine, okay, and then form this compound. So it will eliminate H2O, you take the OH from the carboxylic acid and then one hydrogen from the amine, right, and the N attached to the C double bond O and then CH3, so it will form the compound. So this is the popular question, popular question. How to form an amide, right, from benzene ring. Okay, so if you want to make sure that the N attached to the benzene ring, right, so you will react with it will undergo nitration, the electrophilic aromatic substitution, nitration by using concentrated H2SO4 and concentrated nitric acid 50 to 55 degrees Celsius. After that, you reduce it and then form amine, and then amine react with the derivative of carboxylic acid, which is acyl, okay, and then form this compound. If you want, right, the benzene rings attached with the C double bond O, then only form amide, right? This one you have to undergo Fieldcraft alkylation first, one of the electrophilic aromatic substitution, and then you have to oxidize the toluene and then form benzoic acid, and then benzoic acid react with amine. Okay, so question 10 is a popular question, okay, to show the synthesis of amide compound from benzene ring. Okay, next question number 11. Suggest a chemical test to differentiate aniline and benzylamide. Benzylamide means carboxylamide, C double bond O and H. So in this case, right, I know this one is primary aromatic. Okay, primary aromatic aniline. So I can use bromine water. because there is a test, right, it's quite similar with phenol. Okay, the name of the test is, okay, let's check. What is the name of the test? The test is reaction with bromine water. Okay, you just write down reaction with bromine water. So aniline, right, react with bromine in water, it will form, okay, this one is position number 1. So 2, 4, 6 tribromoaniline. So white precipitate is formed. So this is the equation. So test, right, is reaction with bromine water. Reaction with, okay, bromine water. Okay, what is the reagent? The reagent is bromine in water. Okay, and then equation 1, observation 1. So this observation 1, right, is give the positive test, which is white precipitate is formed when bromine water is added with to aniline. Okay, and then equation 2 is the benzyl amide. So this is equation 2. Okay, and then observation 2. So the mixture remain no change. Or you can write down, right, no white precipitate is formed. No white precipitate is formed. Okay, is formed. Because as I guide you all before, right, okay, you have to write down something, okay, reverse from the opposite from the positive result. So no observable change. So this is the way to answer the chemical test. Now we look at question B, ethane amine and anti-ethane amine. So ethane amine is primary amine, and the NN, right, is tertiary amine. So we can use nitrous acid test or Hinsberg test. So this answer I given is nitrous acid test. So you have to tell me the name of the test. So the name, right, is nitrous acid test. So what is the reagent? Okay, please follow. The reagent, right, is, okay, Na, NO2, you just follow HCl. And then what is the condition? The condition, right, have to be specific. The condition is 0 to 5 degrees Celsius. You have to follow this one. Okay. Okay, you check for, okay, let's check for the lecturers for the nitrous acid test. Okay, reaction with nitrous acid. Okay, and NaNO2 HCl is the reagent, and then the temperature, right, is 0 to 5 degrees Celsius. Normally we write as 0 to 5 degrees Celsius. Okay, so for the primary amine, right, okay, this is the way to write down the reagent, the condition for the equation, and then from alkene, alcohol, haloalkene, and nitrogen gas. So that's why, right, the observation is gas bubbles release or gas bubble evolve. So this is the name, okay, the reagent, and then condition, equation 1, observation 1. And then equation 2 for tertiary amine, right, when react with nitrous acid, it will form the salt, okay, salt. Okay, as you guys all just now, right, okay, you have to bracket. Okay, actually no need bracket also doesn't matter, it's acceptable. But just remember nitrogen with positive charge and then the chlorine with negative charge. Here also the same, nitrogen with positive charge and then the chlorine with negative charge, NOCl. Okay, so here no observable change, or you have to write down no gas bubble release. Okay, release. Yeah, so write a proper one. Okay, you just write down release. Hello, Madam Kong, what happened? Release. Okay. Okay, now we proceed with the, okay, you also can use Hinsberg test, no problem. For Hinsberg test, right, you remember there are two observations. The first one, right, when react with excess KOH, right, for primary amine, right, it will form a clear solution, and then continue with acidify, react with HCl, it will form white precipitate. If for tertiary amine, right, no observable change when react with the excess KOH, and then form clear solution when react with the HCl. You can refer to here. Okay, Hinsberg test is this one. Okay, primary, clear solution, and then white precipitate. Okay, for tertiary, no observable change, and then water soluble salt form clear solution. Okay, now we go for the last question. Question number 12 is deduce. Okay, the question deduce. When a compound with molecular formula, so I always write, guide you all, must explain each of the statement. So for this statement, right, you notice, right, the ratio for C, okay, to H is 1 to 1, meaning that this compound, right, with benzene ring, okay, because the ratio of the C and H is 1 to 1. Okay, so this compound is benzene ring. Okay, 1 to 1. So Higgs first test, okay, reagent, and then nitrous acid test. So using both chemical tests. So the observation when addition of KOH clear solution and then form white precipitate. So I know this is primary amine. So this one is primary aromatic amine. Okay. And then nitrous acid test, no nitrogen gas is released below. Okay, confirm already. So this is aromatic. Okay, aromatic amine. Okay, but there are one carbon, right? So meaning that okay, this carbon sure will attach with benzene ring. Sure will attach with aniline. Okay, NH2, and then there's another CH3. Okay, let's check for the number of hydrogen. Is it tally? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, C7H9N. Okay, I think this is the structure already. Okay, based on the above observation, draw the one possible. So this is one possible structure for C7H9N and write all the equation involved. So I deduce this is the answer. Okay, check, isn't it? Yeah, this is the answer. Okay, maybe some of you might ask me, why, madam, the position is 1, 3? Because, right, okay, there is a auto meta para, okay, rules, right? Okay, if O means 1, 2, if the 1, 2 compound is produced, right, normally come together with OMPP, okay, 1, 4. So in this case, right, the hints given here draw one possible. So meaning that normally if one product is formed, right, normally the position for the compound, right, is meta, which is 1, 3. Okay, there are some rules applied for this concept, but this is our syllabus. So if the question, right, just ask for one compound, right, definitely is meta position 1, 3. So this is the answer. Okay, so you have to try to show the 4-methyl aniline react with benzene sulfonyl chloride, okay, with benzene sulfonyl chloride in excess, okay, excess insists excess KOH. If you want to straight away show the N negative, K positive, right, so you must use excess KOH. If you use KOH, right, you have to show the white precipitate product, okay. Since this case directly show the product, right, clear solution, we have to use excess KOH. Okay, so the clear solution, the soluble salt is formed, and then react with HCl, it will form the white precipitate because no more hydrogen atom, okay, for the nitrogen. So, okay, white precipitate is formed. Okay, if with nitric acid, right, okay, if you form, okay, the salt, okay, this is salt, okay, benzene, this is salt as well, okay, and then this is aromatic amine, okay. Oh, the answer given here, right, oh, for another 3, okay. So this is 1, 4, 1, 3, and 1, 2. Okay, so acceptable. Okay, since our syllabus, right, so all the 1, 2, 1, 3, 1, 4 answer is acceptable. Okay. Okay. As I say, right, you have to mention, you have to explain this one. You must jot down this point. Okay. So you explain already with Higgs test. Okay, why this one you no need to explain, because observation is given. Okay, observation is given. So what you need to do, right, you just have to write down the equation. Okay, so that's all for this video. Okay, you can check for another video for the objective discussion. Okay, thank you so much. Okay, hope you really understand this topic. Practice make perfect. Okay, you can do it. Bye. See you on next video.
Thanks for watching. Please do remember subscribe, like and share Coach Ling channel. You can follow my Facebook, TikTok and IG as well. See you all again on next video. Bye bye.